Alright, so this is Mcf3m, and we are working on question 52, number 8 today. The question is, if the height in meters of a ball in t seconds, so h represents height, t represents time in seconds, the height in meters of a ball t seconds after being thrown is modeled by this function, minus 4.9 bracket t minus 2 squared plus 45. Question A says, from what height is the ball thrown? We can calculate the initial height of the ball being thrown by converting this equation, which is currently in vertex form, into standard form. Standard form is represented by h of t equals ax squared plus bx plus c. The way we can convert this is through FOIL, or first outside, inside, last. The way we're going to do this is we're going to do t minus 2 brackets t minus 2, because t minus 2 squared is t minus 2 times t minus 2. So it's going to be t minus 2 times t minus 2. On the outside, we're going to have plus 45, and over here we're going to have our minus 4.9. And then we're going to have h of t. Okay? So, we're going to simply FOIL. First, outside, inside, last. That means t is going to be multiplied by t, and then by 2, and then 2 is going to be multiplied by t, and 2 is going to be multiplied by minus 2. And then, once we're done, we're all going to be multiplied by minus 4.9. So, minus 4.9 stays on the outside. We have t squared minus 2t plus 2t, this is all in brackets, remember, plus 4 in brackets. Then we're going to multiply minus 4.9 by t squared to get minus 4.9 t squared, and then this becomes 4t, because minus 2t minus 2t plus 2t equals minus 4t. Minus 4t multiplied by minus 4.9 equals 19.6 t. So that's minus 19.6 t. And then minus 4.9 times 4 is minus 19.6 plus 45. Minus 19.6 plus 45. So the equation, when it's all said and done, comes out to h of t equals minus 4.9 t squared minus 19.6 t plus 25.4 meters. Because this is c, this is the y-intercept. The y-intercept was the initial height of which the ball is thrown. Here is a visual representation of that equation in a graph. You can see the initial height of the ball was at approximately 25 meters. So 25.4 meters is the answer to question 8a. What was the initial height of the ball when it was thrown? That's 25.4 meters. So now that we've done A, we're just going to erase this for a second and move on to B. Question 8b says, what is the maximum height of the ball and when does this occur? The way we can find the maximum height of the ball and when it occurs is by simply looking at the vertex. And since the equation is already in vertex form, we know the maximum height of the ball to be 45 meters, as the vertex is a maximum because it opens downward due to the compression factor of minus 4.9. So because it is minus 4.9, the graph is compressed and opens downward. So this is the maximum height, and it occurs at 2 seconds. So for question 8a, what was the maximum height and when does it occur? The maximum height is 45 meters, and it occurs at 2 seconds. and then from there on the parabola continues downward. Here's another visual representation. You can see the maximum height to be 45 meters up here, and then the parabola continues to fall. That was B, 8B. Now for 8C, it asks us to define the range of this function. The range of this function, because the function is represented as h of t, instead of y being the coefficient of the range, we are going to use h. So the range is going to be represented as h e r, or h, any real number, and then h is also equal to, so any number equal to or more than 0 is h, and any number that is less than 45. So the range can be any real number, or it can also be any number that is above 0, equal to or above 0, and any number that is equal to or below 45. Okay? So that is our range for this function. Question D says, use a graphing calculator to graph the function. Determine how long it takes for the ball to land. So we've done that already here on the graphing calculator. This is the visual representation. The ball has gone up, and at this point in time, the ball has taken 5 seconds to reach 0 meters, or the end of the travel path. The approximate time it takes for this to occur is 5 seconds. We know this because the x-intercept here is -1, and the x-intercept up here is 4. So from a height of 0 to a height of 0 again, the total time in between is calculated as 5 seconds, and this can be calculated by taking the x-intercept of -1, 0, and 4, 0, and by adding -1 plus 4, we can determine 1 plus 4 is determined as 5. So we can determine it takes 5 seconds from one x-intercept to the other. So once again, the approximate time is 5 seconds, and we know this because we can look at the x-intercepts and calculate the distance in between in time, represented as a unit of seconds. So that's the answer to D. And finally, for part E, we are going to calculate the domain of this function. So for part E, okay, E says write the domain of the function. So the domain of the function is going to be represented by time in seconds. So T, E, R. Or 0 is equal to any number that T is equal to any number that is greater than or equal to 0. Okay? So that is determined as the domain of the function. Remember, domain is the x values, range is y values. Remember that when you're calculating domain and range. So that is how we solve a